Hi everybody, welcome back to Dave's Math channel. I'm your host David Tare. This is my continuing feature on the Math Lovers book. And as I do every Saturday, I'm featuring a biography of a famous mathematician today. I'm featuring chronologically. I have 80, which I feature in my second volume, the end of the second volume. I'm up to the 17th of them, and that one is Marin Mersenne, who lived from 1588 to 1648. Here's a picture of him, and here's what I say about him in my book. And he was kind of a Renaissance man, I guess. He was a theologian. He was French, and he was a theologian as well as a philosopher, a mathematician, and a musician. So he did a lot of different stuff. But his mathematical claim to fame was what have become known as Mersenne primes. These are primes of the form 2 to the p minus 1, 2 to little p minus 1. That's how it's usually written. And it turns out that these are numbers are only prime. They're usually written as capital P equals 2 to the little p minus 1, or sometimes capital M sub p. And it turns out p has to be prime. This is a necessary but not a sufficient condition, as I think you can see from this table. This table shows the first 64 prime numbers, and then in light blue, the ones that are highlighted in light blue are the exponents of Mersenne primes. So you can see that for most of these primes, 2 to the p minus 1 is not prime. The first counterexample is 11. 2 to the 11th minus 1 is not prime. That's composite. It's 23 times 89. But all the ones shown in light blue here are prime. They're pretty rare, actually. I think there's only 12 of them. 12 out of the first 64 primes give rise to exponents of Mersenne primes. And these things grow really, really fast, too. I mean, 2 to the 127 minus 1. This one has 39 digits. The largest one shown on this table has 39 digits. This was actually found by hand in 1876. I think this was the largest prime ever to be known to be prime and calculated by hand. It was done by a famous French mathematician named Edouard Lucas. I think around in the late 19th century, 1876. The reason why these are easy to find is there's a very fast algorithm for determining whether they're prime. It's easier to determine whether Mersenne primes are prime versus primes, arbitrary primes of the same size. That's why for most of history, the largest known primes have been Mersenne primes, including the largest known one today. I'll get to that one later. That's a prime with I think almost over 50 million digits, a huge prime. But there's one more thing one more other thing. Mersenne lived in the 16th century. He didn't have a means for determining whether the largest of these numbers that he conjectured were prime. It turned out he made 3 mistakes, or 5 mistakes. There were 3 exponents which he thought led to Mersenne primes, but they didn't. The 3 that failed, or there were 3 that, which ones? I think there were 2 that failed, 67 and 257. He conjectured the 2 to the 67 minus 1 and 2 to the 257 minus 1 were prime. I believe it was in 1903 that there was a mathematician who actually proved that 2 to the 67 minus 1 was composite, and he found the factors of this number, and he gave a lecture at the American Mathematical Society that year. And all he did, the entire lecture, was he wrote down the 2 factors, the 2 prime factors of 2 to the 67 minus 1. And there were no computers at that time, so he wrote them on the board, and he did shift and add multiplication of those 2 factors and showed that it was equal to 2 to the 67 minus 1. He didn't say anything, and I guess the audience was so impressed that they applauded him afterwards. So pretty pretty amazing demonstration. And then, yeah, so not every number on this list that Mersenne expected was prime is, but he got most of them right. And what else can I say? Here's a list of the first 22 Mersenne primes. Like I said, they grow very, very fast. Only the first 12 were discovered without the aid of computers. I think all the other ones were discovered after 1950. The biggest one known now, I think, is the 57. There's 52 Mersenne primes that are currently known. So 40 of them were discovered with computers. And this is just the first 22 out of 52. And they don't even list all the digits. They tell you how many digits. I mean, already the 22nd Mersenne prime has, I think, what is it? 2,993 digits, almost 3,000 digits. So these things grow very, very fast. And here's a nice graph. This is the base 2 logarithm of the base 2 logarithm of the nth Mersenne prime. And I think this isn't quite up to date. It only has 51 of them. There's actually 52nd that was discovered, I think, just earlier this year. And you'll notice that they seem to form a line when you do the base 2 logarithm to the base 2 logarithm. This means they're growing extremely fast, by the way, because logarithms are very slowly growing functions. But there was actually, I think it was Pomerantz and Lenstra and another guy, Wagstaff, I think, who conjectured that these Mersenne primes should be congregate around this line, and they even computed the slope and intercept of this line. So the line is shown in this graph, and it seems to obey this, although nobody's proven it. Kind of interesting. It would be really interesting if somebody actually proved this conjecture. If it's true, it would also be known as infinitely many Mersenne primes. That's not even known. It's strongly suspected. I think just about every mathematician in the world who studied Mersenne prime believes there's infinitely many, but nobody's proven that. And what else can I say? The largest known prime, the largest currently known prime, yeah, I guess it's not quite 50 million digits, it's 41 million digits. But this is the largest currently known prime. As you can see, it is a Mersenne prime. And the exponent is 136,279,841. Huge number. But it's known to be prime. And I think the last 20 or so Mersenne primes that were discovered were all discovered as part of GIMPs. It's a Great Internet Mersenne Prime Search. So you can look for a Mersenne prime if you want. Very unlikely you'll find one, but all you have to do is run the software tested on a particular prime exponent. It's very unlikely that it will be prime, but you never know. You might get lucky, and you might get your name on their list. I haven't done so. I found some other types of primes known as Proth primes. Actually, at one point, I discovered a prime that was on the top 1,000, the list of the top 1,000 known largest primes known. It was a Proth prime, not a Mersenne prime. Now I think it's ranked number 30,000 or something. People are discovering bigger and bigger primes all the time. But yeah, and this is just a list. I mean, this kind of is testimony to computer power. So this is a list of the largest known prime during the computer age from 1950 till today, and this is I guess a regular log plot of the size, and you can see in the 1950s the largest known prime only had about 100 digits. Now it has 40 million digits, like I said. And another thing I want to say about this is, like I said, for most of history, the largest known prime has been a Mersenne prime, but there's been, I think, 6 exceptions throughout history, and the last of those exceptions was from 1989 to 1992. The largest known prime during that period was not a Mersenne prime, and this happens when there's a big gap between Mersenne primes, and it turned out there was. I think it was in 1992. the Mersenne prime with exponent, what was it? I have to look at the table again. Well, you can see the gap here between the 31st and 32nd prime. The exponent was about 700,000, and the previous largest exponent was only about 200,000. So there was a big gap, and it was kind of hard to find the next one. That's why there were bigger primes known than the next one, and that's pretty rare. I think the previous time that happened was right before the beginning of the computer age. There was a big gap between the exponent 127 and 521. I think you can see that further to the left. That was between the 12th and 13th Mersenne prime, and there were a couple bigger primes into the 127 minus 1 that were discovered before the next Mersenne prime. But if you want to look for the largest known prime, you're best off looking for Mersenne primes. And that completes my video for today. That completes my feature on Marin Mersenne. Thank you for watching. Long live math, and I'll see you guys next time. Bye.